Welcome friends. Let me introduce a logic analyzer, a useful debugging tool for analyzing digital signals and protocols. I needed this tool to analyze the I2C signals between an Arduino UNO and a BMP280 sensor board. I found a simple, PC-based, 8-channel logic analyzer, which is very affordable too. The maximum clock frequency is 24 MHz. The logic analyzer can be connected to a PC using a USB cable. There is a 10-pin connector provided on it for connecting the jumper wire probes. In this diagram, a connection example for I2C debugging is shown. I used a breadboard to tap the I2C signal connections. Let me show my setup next. The software for the logic analyzer could be downloaded from this site as shown. After the installation is completed, launch the tool by double-clicking on the icon, while keeping the logic analyzer connected to a USB port of the PC. The GUI is simple and user-friendly. The channels are visible on the left. The configuration menu is on the right. After you launch the tool for the very first time, it provides a short tour to make yourself familiar with the menus. It's important to note that there are numerous extensions available for various communication protocols and sensors, making this tool highly versatile. These extensions are incredibly useful and add to the overall functionality of the tool. You could also create your own extension using the guideline provided. The right extension helps in interpreting and presenting the data in a comprehensive manner to quickly see what is going on. To troubleshoot the communication between the Arduino UNO board and the sensor via I2C interface, I need to install the relevant extensions. the channel labels could be modified as required. The last configuration is stored by default. Let me clear those first, before I start a new configuration. Now that I have labeled the channels to indicate the name of the signals connected, I will set up the trigger menu. A simple logic would be to trigger on the rising edge of the BMP clock. You could also set the duration of the pre-trigger and post-trigger events to be stored for analysis. I have kept these to duration as 1 second each. You could also increase the memory buffer size if needed to store more data. Next, I will open the Arduino sketch and upload the program to the UNO board. I am using DF Robot BMP280 example sketch here. The sketch is straightforward. It uses DF Robot's BMP280 library for the Arduino UNO board to read the temperature and pressure data from the sensor over I2C bus. Based on the temperature and pressure, altitude is calculated. These three data are printed on the serial port every second. I will now select the right board and upload the program into UNO. I will now open the serial monitor tool to view the sensor data. Looks like the data is wrong. The room temperature here can't be minus 146 degrees Celsius. In this situation, the logic analyzer becomes an essential tool, as I should be able to see what transactions are taking place on the I2C bus. I will check the settings once more before running the analyzer. It seems that the logic analyzer has recorded some transactions on the I2C bus. However, the abundance of ones and zeros is making it challenging to comprehend the situation. I wonder if the I2C extensions I installed earlier could be useful in this situation. I will check by utilizing the I2C extension functions. Indeed, that helps. I could now easily see the I2C address being driven by UNO, the addresses of the registers read and the data bytes sent by the sensor. On the right-hand side of the trigger view window, timestamps for each event are recorded. These timestamps can help identify any unintended delays or timing issues. Next, I will attempt to use another extension, the I2C transaction function. Please note that I2C transactions are overlaid on the I2C clock and data signal waveforms. By clicking on a transaction, it will display the start and end points of that transaction on the BMP280 I2C data signal. From what I can tell, the Arduino is correctly driving the I2C address, which is hex 76, and the register address is also correct. However, the temperature data being sent back by the sensor is all zeros, which is not the expected result. Upon further analysis, I discovered that there seems to be an issue with the sensor. Before checking the sensor, I took some time to explore other helpful menus on the tool. I attempted to fix the faulty sensor by doing solder touch-ups on the pins, but unfortunately, it was unsuccessful. Therefore, I replaced it with a new BMP280. I connected it to the breadboard in the same way as before, and it appears to be producing valid data. I also noticed that the logic analyzer is showing the transactions. There is a popular saying, "Seeing is believing." The tool helps us in seeing things that we can't see otherwise. This helps in easing analyzing and finding faults. Hope this video would be useful for you too. Thank you for watching. See you again.